My name's Steve Abbott. I'm the president of Stark Safety Consultants, and I will be presenting today for EasyPower's Thursday webinar series, and our topic will be the arc flash risk assessment, and specifically talking about the RFP, the request for proposal, and the details relating to that. As I go over a couple housekeeping items, I'm going to actually launch the first of a few of our polls today. And this will just kind of get us rolling with where people are at. So what we're looking to see is at this point who has actually had an arc flash analysis done. So if you would go ahead and make your selection. So we'll wait one more moment here. We'll close this poll and we'll go ahead and show you the results of those polls here in a second. So we'll go ahead and share the results, and for the most part, at least the people that are on here, looks like the poll number is significant to people who have had an evaluation. So what we're going to talk about today, you'll clearly see that this can help both doing a new study as well as reviewing the study criteria that you had done. So again, my name is Steve Abbott. I'm the president of Stark Safety Consultants. We're based in Canton, Ohio, and we have roughly 25 years experience with electrical safety programs and arc flash analysis, project management, and engineering. And just moving along here for time's sake, real quick disclaimer on the presentation today. This is not intended to provide all details needed for a compliant or a complete RFP, request for proposal, for your arc flash risk assessment. This is actually a webinar that has been converted into an excerpt from a full Stark Safety Consultant 4-hour course, which is the arc flash risk assessment project lifecycle and process. It is available as an online course on qualifiedsafety.com, which is our online training platform. So if you're interested in expanding on the material today, we do have a 4-hour version of this, which goes into a lot more depth. So as we talk about the RFP, you can probably simplify this into one real clear statement. And rule number one, lack of direction is implied direction. So when we start talking about your request for proposal, whether you are trying to create a request for an arc flash risk assessment proposal or you're reviewing proposals that have been submitted, be specific. You're only going to get what you ask for, and if you don't ask for it, who knows what you're going to get. The analogy I use all the time, and I'll just use this for time's sake and simplicity, is if you tell somebody you want to buy a car, it's a pretty broad statement. What color? Is it a 2-door? Is it a 4-door? Is it a Corvette or a Chevette? So we need to be specific when we talk about the arc flash risk assessment. That's really what we're going to try to dig into today. Talk about all of the variables that will have a huge impact on price, have a huge impact on you if you're trying to compare apples to apples. And again, just trying to know that what you have is something that you can count on, rely on, and for the sole purpose of what we're doing the arc flash risk assessment for, hopefully it's not just to check a box off, but it's hopefully to eliminate the risk of an arc flash and other electrical related hazards in the workplace, as well as ensure that somebody's not going to be involved in a situation that requires serious medical attention or potentially life-threatening injuries. So this is just a brief summary of the sections in an RFP that we're going to talk about, and it doesn't include every possible thing. We're not talking about dollars and cents. We're not talking about legal aspects from accounting or other aspects that may need to be a part of the process. We're going to try to talk specifically about a lot of the variables that could be, should be, and might be included in the request for an arc flash risk assessment proposal. So we're going to get into the aspects of data collection and who's going to be involved with the data collection, how it's going to be done, some of the actual, I guess you'd call the actual manipulation of the material, so the modeling of that data, the analysis of that data, engineering components as well as the final deliverables and all the different things that can go along with it. Should they all be incorporated with it, or how can we break that out? Talking about system improvements. Once we've identified the hazards, what can we do to make the system better, and how and what would you want to include in your RFP to accomplish that? Some study upkeep issues. Hopefully we'll get time to go deeper into the fact that this is an ongoing process, and the best investment saver is to continue to manipulate your system and upkeep your system, and not just let it sit until the next time you have to do some updating. We'll also talk about some additional scope, things that can be done, some other tasks that can be done while you're in the process of doing your arc flash analysis or arc flash risk assessment. And we'll talk about probably the most important in the current climate that we have in the standards and industry consensus documents, and that is including the component of risk. And I'll leave it at that right now, but we'll definitely talk about the actual risk assessment component. We'll get in briefly. We won't get too deep into the arc flash warning labels, but we will talk about a few common things to address in the warning labels. And then I'll leave you with just some simple checks when you're writing the RFP, as well as simple checks when you're getting the proposals back that are being submitted. Things that you might want to check for. We're not going to get too technical, but just hopefully some red flags that can catch your eye that definitely could make a big difference in the comparing of one proposal from a service provider to another and the meanings behind them. So we'll start with probably the most important or most telling as far as what can contribute a lot to the actual cost and time to do an arc flash risk assessment, and that's what should actually be included. And we're talking specifically now about what part of the system. And the first one that always comes out and people will talk about is IEEE 1584. And so now when you're writing your RFP and keeping that context in mind, that the more specific you are, the better your RFP is going to be, the more consistent your different proposals are going to be that you're going to be getting back, and the more easy it's going to be for you to compare apples to apples. So are you listing in your RFP specifying the less than 240 volt and less than 125 kVA transformer statement that's in the IEEE 1584? And what does that mean to the rest of your system that's not being included? We'll talk about what we're really getting here as far as the overall system analysis, the overall documentation, as well as your safety plan and safety process. I just spell out here, one little statement that always seems to be missed in conversation. Section 4.1 in IEEE 1584 is a disclaimer that says, this is a guide. This guide is not a mandatory document, and nor is it something that can guarantee safety. So be very careful. I hear a lot of people say this is the law, this is what you have to use for doing an arc flash calculation, and this determines what gets included and what doesn't get included. They've made it very clear in the document that it's not, I hate to say it this way, it's not the end-all be-all, it's not the final word. You still, as the facility owner, are going to have to stand by how and what you do in your arc flash risk assessment, or more importantly, what you don't do. And so want to give again the thought, our goal and our purpose is to make sure people are safe. So if we're using this, what does that mean to the rest of our system and how we communicate to our workers? Again, we want to be clear in our RFP and specify that information. Again, looking a little further into some of the other industry standards, the 2015 NFPA 70E in part 130.3, it's a little broader in that statement. So we're just trying to tie together the IEEE 1584 commentary on what to include, what not to include. The 2015 NFPA 70E goes broader, as I said, and now it's when you work on when you're working while exposed to electrical hazards, you need to have appropriate safety-related work practices, and by way of doing a shock and arc flash risk assessment. So it really doesn't get too specific at this point. The document has changed over the last couple cycles and how specific, but it does tell us that we have to assess the hazard. We have to do some type of assessment. And so what does OSHA actually say? So we'll look at that and go a little deeper. Apologize, this is probably the most wordy part of the presentation here. Some excerpts from OSHA 1910-132, specifically dealing with personal protective equipment and other protective equipment where there is potentially a hazard that could cause somebody injury or impairment. So the employer has to provide PPE. Further on, looking at 1910-132D, the part of a hazard assessment and equipment selection, 132D1 basically says that the employer has to do an assessment. It doesn't specify all the details of where or how, but you have to do an assessment to determine whether the hazard could be present, and that you select the type of PPE based on what you've identified in your hazard assessment. So your PPE has to be based on something. So the comment here would be very conscious of, if you use the less than 240 volt exception in IEEE 1584, more than that, be very conscious of what you're going to do for that equipment that falls below that, and how you're going to document that you've still done an assessment on that. So we've seen a lot of is people will do that, use that exception, and then I'd make any addressing of the equipment that's downstream of that, or even worse, just put a generic label on and not really do any formal assessment as far as that goes. And remember, again, we need to be able to spell out to somebody what it is they need for their safety. And at the end of the day, when you start looking at this slide, after the event happens, is too late to find out that you may not have included something that you should have, or something that may need to be reevaluated. So give that some thought when you don't evaluate the whole system, how you're still going to communicate, how you're going to document that you did an assessment and what the criteria was for that assessment, and how you're going to communicate to the workers they still may need to do something. So let's do another poll here real quick, and this poll is going to be based on what your cutoff point is. If you have done a study, identify where your cutoff point was for doing it. Let's be more specific, doing an incident energy analysis and calculating, not using a table study or not doing anything at all. And if you are currently in the RFP process, what you may already have in your RFP, or what you would consider acceptable at this point. And just give it another 30 seconds here, and we can see quite a broad spectrum here of what people include. Okay, we'll go ahead and close that. Kind of mixed, I would say. Kind of a cross between 480 and above to anything fed from 125 transformer or larger to anything greater than 50. So this is a perfect example of how critical it is in you writing an RFP to specify what that is. That slide right there, that poll, clearly will identify how wide of a range you may get when you're asking for someone to quote-unquote do an arc flash risk assessment and not specify. And be very careful about that. And even if you don't specify, make sure you ask for very, very explicit details in the proposal to explain that process if you want to go that route. If someone's going to use generic labels, there needs to be a basis for why they're using generic labels. If they're going to do a different method for equipment below that, I think that should be spelled out as well. So continuing on, we'll get into, regardless of which method you're going to use or how you're going to make your cutoff, specify. And how do you quantify that? Do you want to use square footage? Probably not the best option, because from one facility to the next, that square footage could vary the number of pieces of equipment. Just specifying by machines may not even be the best approach, because again, it may not include all of the equipment infrastructure that's needed. Our recommendation, best option, is to get a specific inventory and count. Actually just got an RFP sent to us this morning of all time periods that they actually did their own count on their system. They didn't use any parameters of based on IEEE 1584 or based on 480 and above. They literally did a equipment count, and it had so many numbers of disconnects and panels and transformers, etc. And that's what they wanted the quote to be based off of. They didn't want any interpretation of what should be included. They wanted to see specifically the merit of company X versus company Y. This is the number of a piece of equipment that was included. Now let's look at all the other integral parts of what's involved with this proposal and get a true apples to apples comparison. So let's talk about data collection, and the real critical part of doing the incident energy analysis and risk assessment is the information that you're going to use to put into the software program. So, who's involved with doing that field work when you write that RFP? That's a huge difference in cost. And it may not be very apparent, but how much work do you have to do? If you're sending out an RFP, your service provider should be very clear on what they're providing and what they're not providing. A lot of times you may see that you have to map out the system. You have to provide them an accurate feeder system drawing. Be very cautious if accepting any type of existing documents that's not going to involve some type of field verification, whether you're doing that or they're doing that. So we'll get into that here a little bit later, but be very cautious of that. But who's mapping that out? How much work do you have to do prior to them being on site? Creating a consistent and clear name and ID system. It's one that we see quite often in an RFP, that the service provider is requiring the customer to have that completely detailed out. And sometimes if you have an ID system that has anything to do with connectivity, you're really doing a lot of mapping out, before they even come out. So, and then the other one involving some more physical labor is opening cabinets and covers. And so, you start talking about opening cabinets and covers, for every hour that the service provider's on site, you pretty much may end up having to be, hand in hand with them the whole time. So, one proposal that has that included, that they're doing all of that work and they're going to map the system out for you, obviously is going to be a lot more costly than when they're having you map that out. But be conscious, regardless of the price, who ultimately owns that data and who owns the liability for that data being accurate. So if I'm the engineering firm and all we're doing is taking your information and putting it into our software program, we're only responsible that we take that information and put it in the software appropriately, unless your RFP spells out that they have the responsibility for verifying field conditions meet the information that's being provided. So that's a decision you'll definitely want to make, not only from a cost standpoint, a time standpoint, but also, do you want the liability of that information being accurate, or do you want to hire somebody as a service provider and your RFP to make them responsible to have that information done exclusively on their own. And then if you are talking about somebody who is going to collect the data, whether it's your own team, combination of your team, and your service provider, are they qualified to do that? And we can go beyond just the qualification of being qualified from a safety standpoint. Are they electrically qualified to be opening cabinets and being in situations where they may be exposed to energized parts? But also, are we confident, and do they have the ability to prove that they have the experience to know what information that's going to get, so that we can rely on that information, or your own individual people that may not have experience doing this? So this slide just shows a boot camp class that we offer, and it's for the hands-on field work for collecting that information, how to model it or how to document it, how to take photos when photos may actually be necessary, both for documentation and liability. You're out there collecting data on a breaker with an adjustable setting or a programmable setting. It's just your word against the system. With a photo to document the date, the time that photo took place, really has a lot of value for documenting, as well as protecting your liability that that information was the way you said it was when you collected that information, and maybe it may have changed. Someone may have changed it after the fact. But this course, is definitely something that whether you do it internally or your provider provides that assistance, so you hire somebody to come in and maybe provide that assistance to your team so that they get it done correctly and that you have at least the confidence that your scope of the work was done correctly. And just as a little heads up notice that in the fall of 2016, we will be offering our data collection boot camp with the new EasyPower on-site tablet tool to show how to incorporate the ease of that tool in the field and how beneficial it is for collecting that field data. Hopefully easy to see how it makes it a little bit easier for someone to get that information and put it down and be used for the evaluation. So we'll do another quick poll, and that is going to be, what best represents who you had or who you want to be involved with collecting the field data. So if anything, it could be a self-evaluation right now for who you may have in your staff or how you want to specify in your RFP the criteria of who's going to be involved. And you want to keep in mind both the safety aspect, having one person, having two person, versus the convenience and efficiency of having individuals that are qualified to be there. So there may be people that are knowledgeable of what information needs to be documented, but may not have the physical electrical qualifications to be involved with opening cabinets and getting inside cabinets that might be energized, even if we're looking at a situation where we're staying behind the restricted approach boundary just for visual inspection. So we'll give you guys another second here. And for the most part, it looks like, it's kind of a combination. I think clearly it looks like, two people, not only from a safety standpoint, but also convenience standpoint, both engineer and electrician. A lot of benefit for that, especially if you're directly inputting it into the software program and somebody's out there. We use a more general term when we teach a data collection course. There's a recorder and there's a collector. And the collector is usually the one with more hands-on experience and knowledge, opening cabinets and doors and covers and knowing what they're looking for when they're inside the cabinet. And the recorder, somebody that has more engineering experience, somebody that has more knowledge of the ArcFlash software program that's being used to input that information and be able to see the big picture of what might be missing. So so clearly that seems to be the consensus from everyone else as well. So we get into just a couple other quick things related to the actual analysis process for the RFP. We'll start with some of the modeling and analysis pieces. And in your RFP, definitely give some thought to the software that you want to use. Preferably for this presentation, EasyPower would be the choice product. But not only for doing the base study, but also what are your long-term intentions? Do you want the study to be done in the software that you're going to be able to use yourself, and that you're going to buy your own copy of EasyPower when it's done, and that you can simply learn how to use? Or are you going to not really care and let somebody else do it for you long term? Also, if you have other facilities, it makes sense to provide some consistency and use the same software. So you'd want to at least address that both from the front end and the back end. And also some of the details of the software and the process itself. So what type of coordination methods and reporting details are you going to request? What type of time current curve reporting details? And what I mean by that is, do you want a time current curve provided for every device that has an adjustable setting? Or do you want a time current curve for every device that is showing that is not coordinated either in series or in parallel? So be specific, because if you have a big system, that could be a lot of additional scope, a lot of additional work. So be very conscious of what do you want that for, and really it's how much work do you want the service provider from an engineering standpoint to perform for you, or do you want the base study done, and do you want the software file, and you want to take it and then start doing some of your review of the coordination and system improvements, which we'll talk about. But that can have a huge impact on dollars and cents and time. So think about why you're asking for it before you just put a boilerplate template together and say, hey, we want a time current curve for every device, or every device that's got an adjustable setting, etc. There's reasons for that, and again, you can pull that up from EasyPower in the software at any time. So again, think about your long-term approach and what you're going to have and why you're going to have it. Probably the biggest one with respect to the system analysis, in my opinion, is the assumption process. And there's language that's in IEEE 1584 with respect to engineered assumptions. But there's also language in IEEE 1584A and the 2013 edition of the IEEE 1584 as far as concerns over making assumptions. So be careful about that in your RFP. I would suggest in your RFP you create some language in there that possibly even list what assumptions are allowable. Or actually what might even be better is specifying no assumptions are allowable unless they are communicated to you up front and you give approval. So a logical assumption could be the main substation gear couldn't be shut off during the time of the data collection, and there was information that couldn't be gathered because it couldn't be opened up. That should be communicated to you at that time, and you should ultimately be in a position to make the final decision of whether or not you're going to allow an engineered assumption, even hopefully just a temporary assumption, until the facility can shut that down, and then get that piece of equipment evaluated again once that piece of equipment has been verified. But the worst thing is not knowing. We find a lot of our clients that we deal with reviewing, and doing gap analysis on existing studies will find that they were not even aware that assumptions were made until they were provided the material. Some really bad situations where they didn't even know about it until we pointed it out to them months or years after the study was provided to them, and had they known that, they may not have allowed that. So if you're in the RFP stage, I would definitely recommend spelling that out or requiring the RFP or the provider of the proposal to spell out specifically the process that they would be using for doing an assumption, using an assumption, and or how they're going to communicate to the customer for that assumption. And we got one more poll question here. This will be our last poll question, and it's related to what assumptions. It could be assumptions you've already allowed. So it could be a self-inspection for some of your existing studies, and more importantly, what assumptions are you willing to accept? Now, these could just be temporary. So temporary, you still may legitimately have to make an assumption, get your base study, and then you have to go back and, which a lot of times we don't seem to think about, you may have to go back and reevaluate when that information becomes available and verify that. So we'll give everybody here another couple seconds. And again, as everybody's doing this, I see a lot of questions coming up. We will evaluate and go through the questions at the end, and any that we don't have time for, we will still provide a written response. And I'll share those results. Overwhelming that no assumptions will be accepted. I think that is usually the normal comment, but again, be very thorough in your review of proposals, and more importantly, be very thorough in your final deliverables. I see a lot of people that have the no exceptions accepted in their RFP, and the proposal doesn't spell out any assumptions will be made, but then the final deliverables have assumptions. So again, simple statement of having all assumptions must be brought to your attention, as a customer prior to those being allowed to be included in the analysis, probably going to be the most responsible approach and protective approach for you, so that you are in the loop the whole time and can have that evaluate as what's going to be appropriate and when can you deal with that. Some final pieces on engineering and deliverables. Talking about your service provider. Don't be afraid to specify in your RFP some specific requirements for the service provider. Experience. We mentioned some experience already. The person that's in the field needs to be a qualified electrical person. There is going to be a lot of times that you will be either opening a cover while it's energized to visually verify that information, or potentially even turning it off, which is interacting with it. So there's still going to be some level of electrical exposure that we need to deal with even in the data collection phase. Also for the service provider doing the engineering work, and has that person had experience doing power system analysis and incident energy analysis work, and have they had experience doing that type of work on a system like yours or some type of system related to yours. And don't be afraid to ask for examples of their work, as well as references of people that have been involved and gone through the process with the company, and get some recommendations and referrals. But don't be afraid to put that language in there. As far as the deliverables go, things that can affect price obviously is what we're getting at. Do you want digital or do you want hard copies? Obviously hard copies are going to cost more money for printing, so be very specific about what you want and how you want it. Stapled, bound, 3-ring binder, multiple sets, those type of things. And keep in mind, the more equipment in your facility, the more pages, the more trees we kill, so that's a lot more time and money. So that, definitely you want to spell that out. This next one is probably, I don't know how I want to say this, but this one's a real interesting one, and we see this a lot. If you're paying for an incident energy analysis, and we'll say that, or an arc flash risk assessment, that software file should belong to you. It should be specified. I would never recommend creating an RFP and accepting a proposal for someone who is not going to give you that file. It's not an art, it's not an art project or something that's protective of the company who did it. They should be doing it to engineering standards and guidelines. It's nothing secretive. If they do that information, if they do that study for you, that should be something that comes with it. Not just a PDF copy of the drawings or a PDF copy of the report, the actual project software file that allows you to take it, open it up in your version of EasyPower, and be able to not only use it for updating and long-term upkeep, but also to review some of the back-end information to validate that you got information that actually is valid, and also be able to go a little bit deeper into what possible assumptions that were made in the engineering part that they may not have pointed out to you. So that, to me, that is probably one of the more critical items in an RFP, is that we don't see enough of. We don't see that they're specifying that you are requesting and demanding that be a part of the proposal, and making sure that you get it. We've seen a lot of cases where it is in the proposal, but at the back end, they're not validating that information, that document's actually being given to them. Warning labels. Warning labels, with respect to printing and installing, the details related to that, what material to be used. I'm not as concerned, and I don't recommend being so overly concerned about how the label's laid out. More so that if someone's going to create the label for you, they at least give you some details of what needs to be in it and options that could affect price down the road. Labels, again, there are some guidelines. The ANSI Z535 is a guideline for the warning labels. There is some newer language in the 2015 NFPA 70E of what information has to be on the label, but we still see a lot of loose interpretation, a lot of let's just say crazy labels out there. So there isn't, unfortunately, a universal standard of what the label should look like, just information that needs to be on it. So be careful of that. I like the RFP to have some wording in it that they provide samples and if there is any variation of samples that will not affect price, provide all those variations that they want to propose, and any terms or any conditions that will affect price based on how the label is laid out. And labels, keep in mind you have hazard warning labels. You have now, we'll talk about here in a few minutes, the risk assessment component, and then also ID labels. Not every label gets an arc flash warning label, but sometimes it's very helpful to have every component, especially if the component was included in the arc flash risk assessment, to have some formal ID on it or some type of name label on it and some type of consistent labeling that shows it was a part of that particular arc flash risk assessment process. So spell that out as well too, especially if your facility doesn't have consistent naming and you're going through this process. What a perfect time to have that ID or equipment name added to the piece of equipment, especially if it would not have had a arc flash warning label. And then the other piece to this in the deliverable stage is making sure you're clear on what training you're asking for versus study presentation. So we see a lot in proposal that says you have to provide safety training. Be very careful about that and be very clear on what you're asking for. There's a big difference in just presenting the study information and explaining what is there and how you read it versus when you start talking about how you use it. How you use it when you start crossing over into safe work practices. Now you've crossed over into safety, and you've kind of walked away from engineering. So a study presentation, or orientation, predominantly be very clear on the engineering information that you're asking them to explain versus safety training. And when you start talking about that, go back up to the first section here for the service provider. And this is where I would actually recommend you also look at, is the engineering group, do they have the safety qualifications to do the safety training? Or do you need to make sure it's clear that if they are not capable of doing that themselves, they need to also provide the credentials and criteria of a third-party group that they may be using to do the safety training. So be very careful about that. And just a soapbox on safety training. If you're doing the safety training, why not take advantage of your company policy and procedure and make sure that that is included in that training? What's really the value, I guess, is kind of a self-question. What's the value of safety training if it doesn't encompass your safety policy and procedures, which to be a qualified individual, you need that anyway. But that's just kind of a self-auditing question to look at and see the value of that from your end. One other piece with respect to engineering deliverables is the drawings. And when you are specifying what you want in your RFP with respect to drawings, again, whether it's a visual, whether it's detailed information of what you want on the label, keep in mind, or on the drawing, keep in mind the software can input a lot of information without manual manipulation. But there are some things that need to be manually entered. And anything that needs to be manually entered, manipulated, adds time, adds to cost. And that can create a lot of differences in your RFP proposals that come in. The other thing also is, do you want this to be very usable, and who's going to be using it? So it most likely, and some of the most important people are not the people with the engineering background. You want to get it in the hands of the field personnel, or at least be viewable. So having something that is more usable, more user-friendly, again, that drawing that you just saw was the same system, drawn two different ways. So what do you want? But a system drawn like this, there's a little more manual work involved, and it takes more time. But if it's something that makes sense based on what your system is, some of the bubble noting that shows different things from the initial assessment, if you want that, again, specify it. Be very clear, or there's no guarantee that one provider versus the other is going to give you that information. Note that during this process, I didn't talk about system improvements, because I would recommend, and I would clarify, very difficult to include doing hazard mitigation and risk control in a base RFP if you want that priced before the analysis has even been done. If you're trying to come up with ways to reduce hazards and reduce risk, and you're trying to include that in your pricing, that's going to be a lump price or a line item price, before you can even quantify what hazards even exist in the system, it's not a very good formula in my opinion. Having some detail of the process of the maybe a unit pricing or some budget pricing, that is doable and makes more sense. But to require that to be included in your base price, and there's 1,000 pieces of equipment in this building, how do I know what problems are there until the analysis is completed? So that one, be careful about that, and you may have to look for your long-term plan to better address that. The only other thing I'll mention about hazard mitigation and risk control, be careful about setting a, I want to say, line in the sand and say we want everything that's above 8 calories or everything that's above 40 calories to come with a reduction method. I normally would recommend that you as the client look at the base analysis and determine where your priorities want to be for hazard reduction or risk control. Keeping in mind, if you do a lot of recommendations and a lot of mitigation strategies at one time, when you ask for that engineering review, they may be cumulative in the effect that they get. So if let's just simplify and say you ask your provider to come up with 10 recommendations on 10 different pieces of equipment to reduce hazards, and they provide you those 10 recommendations, but you only actually carry out 5 of those. The results may not be the same because the other 5 may have had an impact on the 5 that you chose. So to do something like that in a bulk, so to speak, method may not actually be the best approach, and you may actually have to go back and revalidate some of those recommendations and mitigation strategies.
Another big item of consideration for ongoing updating to your study is how often and what things should we be looking for to update the study. There is some language in the NFPA 70E regarding updating, and this section, unfortunately, most people look at this as one item, but there's actually 2 items in 130.5.2. The first one is when updating the study, it needs to be updated when a major modification or renovation takes place. So that's part 1. Part 2 is it shall be reviewed periodically at intervals not to exceed 5 years to account for changes. So you can look at this 2 ways, and one could be nothing has changed in the facility. You at least need to update that within 5 years. Review it to ensure you've accounted for any system changes, utility data information changes, but you need to update it whenever there's a major modification or renovation. So what's major? And the best interpretation of major that I can give you is major would be anything that would change the work practices someone would normally have been applying to work on that piece of equipment. Due to the change in the system, it affected that. So that's where I would make sure we keep track of what is major, and we don't lose sight of fuse changes, breaker setting changes, transformer changes, reconnecting devices to a different connective device in the system. Those could be major. Those could affect big parts of the system. And the worst case is just saying, well, I don't have to do anything for 5 years, even though I know that that has affected my system. At the end of the day, we're looking at safety, and we should know that those kind of things can affect the calculations. So we want to look at those things and see what it actually does to the system. There are a lot of additional benefits for keeping the study current. Obviously, the things that are more visual, having accurate warning labels, staying up to date with the changes, your drawing staying up to date, or even just putting the red lines on there so people can account for system connectivity changes. But when you start doing risk control methods of improvement and hazard reduction or hazard mitigation strategies, these are going to be able to be much more efficiently and confidently confirmed and validated, because we know that the system connectivity is complete. You think about having those drawings and study up to date from a standpoint of contractors pricing work in the facility. Now the estimates can be done more efficiently, which are going to in turn hopefully result in better pricing because there's no guessing involved. They're going to know where they can, because of connectivity size and load, where they can connect different pieces of equipment and not have to worry about figuring that into our bid because we don't know yet until we get the job. And the system changes can be verified before installation. When you keep things current and up to date, it's going to be a lot easier and quicker to throw something into EasyPower, into the existing model, do a model check, and be proactively knowing that when I install this, it's not going to create a problem that I'm going to have to deal with later. But probably the most beneficial is a safety culture is going to remain the priority. You just think about that 5-year term that's in the NFPA 70E of updating at least once every 5 years. If you wait for 5 years in a system that's changing constantly, what do you really have happen? You know, a stereotypical example is all the focus. Oh, we're doing an arc flash study. We have to, you know, we're going to update our system. We're going to improve our training program. We're going to get PPE for everybody. And then what's the normal human reaction? Nothing changes. Over time, we lose a little focus. There's system changes going on, but we're not updating those, and we still have labels out there, and the workers are aware. They know that, you know, it may not be accurate because they know it's not connected to the upstream device it used to be, and our focus starts to wane, and we start to lose confidence in the information, which also kind of leads us down the road of not, you know, thinking so much of the importance of all of the information, the PPE and our safety program. And then, oh, the 5 years comes back up and, oh, everybody gets high priority again, and we think about that and it's in the forefront. If we keep track of those changes and we keep it current, it's always going to remain as a priority. It's always going to remain in the forefront. And just the workers are going to have that much more confidence in the information that's there, and they're going to be able to rely on it more, which is going to be a lot easier for them to implement any safe work practices that are supposed to be carried out as a part of the information that you're providing in this study. These are just two examples of how we teach tracking of changes in our data collection bootcamp class. The one on the right is just a simple tracking form that just documents when and where by device ID a change took place, where in the building, what potential upstream device it was connected to, so we can kind of show some connectivity, and then just simply, what was it? It was a fuse disconnect switch, it was a non-fuse disconnect switch, it was a 3-pole breaker, and very simply, did we add, remove, replace, or relocate that device, so that we can at least just keep track of changes, and then these sheets can be tabulated over time, and somebody that maybe has a little bit more qualification in documenting and getting the vital information can take these and then go, similarly with a diagram on the left, then go out and actually map those changes and put it on the red line, on the one line where it's appropriate, document everything that would need to be input into the model, and be able to have a nice, clean, consistent red line diagram. And it really doesn't have to be that much more complicated than that. It just needs to be done. And it's like a diet. There's no good time to start better than right now. And, you know, just that ongoing process of sticking with it and being consistent and having somebody that's responsible for getting these sheets, and also even going out and talking to the individuals who may be doing the work in the facility to keep aware of what projects are going on. That's usually going to be the challenge. But when you've addressed that and you find somebody that can keep track of that and knows how to map it out, it's going to be much easier to maintain your system and determine if the information on that diagram on your left is something that, yeah, we really need to put this through the model and check this before it gets installed, or if it has been installed and we find this, we need to plug this in and determine what it could do to the system. Just to summarize again, the type of updates that could happen. Proactive versus retroactive, just simply put, if you can take the information on a design change before you physically install it and put it into the EasyPower model, it's going to be a lot easier to validate and verify if there's any concerns with it before you physically put it in. Once it's in, now it's retroactive, and retroactive is it's there, and if you find a problem, now the only way to correct it is to physically make that correction, and now you don't have the opportunity to possibly just do a simple model change and design change. Model checks versus system update. Model checks, again, are just targeted checks where we can look at just a segment of the model, verify if there's something that significantly could affect the system. And there again, with the proactive updating, putting something in the model, it's still there. May not be a major impact, but we've taken the time in small increments of time, 5, 10, 15, 20 minutes is all we're talking about, to add some different components into the model, so at least it's in the one line. Even if we're not doing a full update, we can at least print out an update to the drawing and have a clean copy that people can then continue to use and a lot easier to interpret. Full system update, obviously when you have a number of these changes over time, you want to do that update so then you can clearly see the full impact of the system, and we just don't go long periods of time without updating when there's a lot of changes. Some additional scope and tasks that can be done in the context of doing your arc flash analysis, predominantly when you're doing the data collection, really all stems around when you have the opportunity to open that cover and open it only one time. Not only the time involved, but also the risk involved of having to open that cover multiple times. So anything you can do while that cover is open, we look to take advantage of. And mostly it's going to be based on photographs and just inspection items, but if I can do infrared scanning while I have that cabinet open, definitely an advantage to do that at that time. Maybe not building equipment-specific lockout tagout procedures, but gathering maybe some additional photos that might be necessary when doing those procedures and getting the inside cabinet photos. Great opportunity to do that. And training material. Can't express the value enough of how helpful a picture of the inside of a cabinet can be for a qualified electrical person to understand what's inside that cabinet before they physically have to go out there and open that cabinet. It's an invaluable tool, and especially control cabinets where there's so many variations and multiple voltages, and knowing where the covered parts are and is it suitably guarded and those type of things. It's a great tool. So if you're interested in doing those type of things, spell that out in the RFP and allow the individual service provider to put that into the context and scope of the cost for them to do that work. And it definitely would be cheaper than going back and doing it at a later date if they can do it all at one time. Preventative maintenance tasks can also be included and done at that time. Visual maintenance inspections. Again, if you can identify that you've done the visual inspection and you can identify in the context of collecting the field data any piece of equipment that's of concern. Common one would be showing signs of water damage and rust that's actually rusted on the inside of the cabinet, excessive dust buildup, any signs of melted wiring and broken components, physical damage item that we have down here. Those are things that if you can put that in the RFP and define how you want them to report that, again, it's going to be a big value and definitely something that from common practice, it's not going to be something that we're going to expect someone to go back and do at a later time just because of the time involved in a big system. But if you can do it when that door's open, that would be a big value. Also addressing in the RFP, how are you going to deal with mismatched fuses? How are you going to correct those when they're found? So if you find different styles, different trip setting, or different brands and types, hopefully not different sizes in the same device, what's going to be the process to make those corrections, and how are you going to deal with that in your calculation? So you want to make sure that those are identified, and more importantly, you want to come up with a plan to correct those if possible before you generate your base calculations, so you have time to make those corrections, and it's going to allow you to do a much better and thorough coordination evaluation and arc flash evaluation. So that's one that pretty common that you're going to find a few of those at best in a facility where there's some mismatched fuses, and addressing that in the RFP is probably going to be the most beneficial.
I've held off to this point to really dig into the next topic area, and that is hazard versus risk. And because now the 2015 NFPA 70E talks about the arc flash risk assessment, there's one very important concern, and that is that the arc flash risk assessment is not the same as just an incident energy analysis. And when someone is proposing an arc flash risk assessment, two things. A lot of you in this group said you've already had an arc flash analysis completed. Have you done the arc flash risk assessment or just the incident energy analysis? And you can go to the definition section in the NFPA 70E now that says the incident energy analysis is now just a component of the overall arc flash risk assessment. So if you've had an arc flash hazard assessment, that doesn't necessarily mean you've completed the arc flash risk assessment. The risk component needs to be included. I think this is a great visual to give us an understanding of the difference between hazard and risk. The hazard may be present at all times. It's based on your exposure to that hazard that determines the likelihood of the hazard injuring you or creating harm. So risk is hazard times exposure, and there is some formulas in the NFPA 70E and Annex F as well as ANSI Z10 that can be used to help determine that risk assessment. So again, be very cautious of the fact that if you have an arc flash assessment completed without the risk, that may not necessarily be a completed process. So per the NFPA 70E here, we see 110.1G, we have the risk assessment procedure. It's a multiple step process. We identify the hazards. For the most part, most people will be considering the arc flash incident energy analysis would be the part of doing that. So we identify the hazards. Then we have to assess the risk, and there is risk. There's a component for estimating the risk and taking a calculation of those risk estimates to determine the level of risk that we actually have. And then we have to determine if the risk is not acceptable, then we have to determine how can we control those risks. And that's where we'll have to do some different type of risk mitigation strategies as well as some hazard mitigation strategies. So, if someone concern is twofold. You have an arc flash hazard analysis label on a piece of equipment that you've done the hazard assessment, and you still have to do the risk assessment. From the RFP standpoint, be very careful. Unfortunately, there's far too many people out there that are saying that they're providing an arc flash risk assessment, but doing the same thing they've been doing for the last 2 years or 2 years ago. So if they're only doing the incident energy calculation without the risk component, then they're missing a big piece to this arc flash risk assessment process. I will say that we have created SARA, the Stark Electrical Risk Assessment Helper. It's a web access tool that you can get a subscription to, and it basically allows you to take your existing hazard assessment, incident energy analysis information, and then do the risk assessment component to complete this process. So we've taken the formulas that are in the Annex F of 70E as well as some of the other ANSI standards to make this a simple process. This is not the only way to do it, but it is a simplified tool that's available. Bottom line is it needs to be done. And again, just looking at the warning label, we only see hazard information. So if this is an existing label that we have out there, there needs to be something encompassed in our RFP that spells out if we're going to require the provider to do the risk component or just the hazard component. So it could very well be that we're just asking them to do the arc flash component. We want to be very careful that there's not language in there that is also requiring us to get the risk assessment component done. And if it is, then there needs to be some detail on the process and how it's going to be carried out. It could very well just simply being that the risk assessment has been done and been documented, and another piece of information is going to be put on the cabinetry to identify where that risk assessment has been completed and that a person needs to use that in their job planning. And again, I won't get too in-depth with warning labels. Again, ANSI Z535 is where you're going to get your guidelines for warning labels. The NFPA 70E and 130.5 later in this 135.5 section has information on the warning labels. And again, there are some general guidelines. I would simplify this with the colors that you see here: yellow for caution, orange for warning, red for danger. I would just to kind of give you some high points and low points, be very cautious of using other colors or other images outside of what the ANSI Z535 spells out. Again, it just It's going to be easier if there's an accident for someone to go and point out that could have been where there was confusion, because all the other industry standard information gives you some simple guidelines. Don't oversimplify it or try to make it more simple than it really needs to be. Kind of wrap up on the risk assessment. If you're interested, you can email me at steve@starksafetyconsultants.com. It'll be here at the end of the presentation, and we'd be happy to send you a copy of a template risk assessment and some of the formulas that are used for that are in the Annex F of the NFPA 70E. I'll wrap this up with giving you some simple checks when you're writing your RFP, as well as if you are reviewing proposals and also reviewing the final deliverables from a project that you've already completed. So, watch out for the descriptions, as we said earlier. Who's doing the data collection and what part? Clarify the field verification process or lack thereof. So again, are you relying on existing documents in your RFP? Are you requiring that individual to go out and field verify all that information? Is there any reference in the proposal that you get that references a partial system study, especially if your RFP did not define that clearly enough? So you're going to want to look for those type of things. Hopefully your RFP is pretty clear cut. Is there any reference to any assumptions that are being made in the proposal or also the deliverables? And then what are the criteria for those assumptions that were being made? So look for those type of things. Usually you're going to be able to see that in the report and the finished study in the first or one or two sections of that report. It's going to spell out what assumptions were made, if any, and why they were made. So you want to be careful and look at that. Any reference to what work you're going to have to do. If it spells out that you have to provide a labor for this or for that, if you have to install the labels. I've even seen proposals where it says the labels are being divided into two groups, ones that we've calculated, ones that are generic. We're going to install the ones that are calculated, and we're giving you the labels that are generic, and you put them on. So I've seen some language like that in quite a few proposals, so you really want to be cautious of that. When you write the RFP, again, be specific and make sure you address those things and spell those out. Is the hazard assessment and the risk assessment being done, and how is it being done? Is it being done, do you want it specifically done for every piece of equipment in the analysis? Do you want a template to be created that can be used and incorporated into the electrical safety policy? A couple different ways to do it. Again, what formula, what method? Annex F actually has in 70E several different calculation formulas to use. So if you're telling someone to do that, you probably want to be specific about that. I will also reference we do have a 4-hour how to perform the risk assessment course. There's a lot involved with that. So, I know we're covering this in a short period of time, and we've actually gone beyond the time length here, but define the improvement process. Do you want hazard mitigation strategies included? If you're not going to include that in the base quote because it's hard to quantify that, then define the process you want to be done, or request them each to provide their own proposed process so that you can evaluate that. And define the before, the during, and after of doing this assessment. So before you even start a big facility. We did a facility not too long ago that had almost 20,000 warning labels in it. There's a lot that happens out there from the time you collect the data till the label actually goes on. So before would also be defining how are you going to ensure that the system changes that happen in a big manufacturing plant, they're happening every day. How are we going to account for that during the scheduled time frame it's going to take to complete the data collection, do the analysis, and finish the study and deliverables? There could be an enormous amount of changes take place, and the worst thing would be to go through this process and at the culmination, at the very moment that it's done, realize it's already inaccurate and outdated. So starting a process before of how you're going to keep track of those changes, and almost a staged approach possibly to be able to continually to get that updated information and add it in before a certain point. During, when you find problems, how are you going to address them? Are they going to be included into the base calculation, or are they going to have to be done afterwards, such as physical damages views problems, other, things that may need to get corrected or fixed that you find, code problems, those type of things. Are you going to include it, or are you going to have to deal with it afterwards? And then, like we said before, the after, still the critical part. What's the long-term approach? How are we going to track the changes? And so that's pretty much the end of what we had. And again, to summarize, this is an excerpt of a much longer, detailed course. If you have any additional questions now, you can hit the raise your hand button. I'll start by going through some of the questions that we had. I apologize for the gap here. We lost some connection. Somebody asking, can you give an example of a risk assessment? Giving an example of a risk assessment is kind of difficult, but keep in mind, it's a calculation. I can tell you from Annex F that it's a 4-part calculation. And the 4 things you have to estimate are severity. So severity, what's the outcome? If it blows up, what's the outcome? And you have to estimate that. So if that blows up, am I going to lose an arm? Am I going to be paralyzed and never be able to work in the trade again? Or am I going to die? So you have to give some type of and that was a very generic quantification of the levels of severity. But so there is some ratings that you have to estimate. That's in Annex F. Then the other 3 have to do with probability and likelihood. So the one is frequency and duration of the task. So we have to estimate that. Is this something that we do 5 times a day? Is this something that we do once a year? And the more times we do it, the higher risk that an accident could happen. Duration of exposure, same thing. If I'm troubleshooting, there's going to be a lot more time that I'm exposed to the hazard versus if I'm just turning the disconnect handle from on to off. So duration of that exposure increases or decreases the risk. And the next one is the probability factors, terminology, they kind of overlap a little bit. But now when we talk about probability and the likelihood of probability, we're dealing with 2 things. We're dealing with equipment conditions. So obviously new versus old, the risk is different. If we have preventative maintenance that is routinely and correctively being done, that changes and increases or decreases the risk. And the second part of likelihood and probability is human factors. So now we're really getting into even specifically who's doing the work. And so this is where you may need to do a risk assessment almost on a task-by-task basis and almost encompassing a component of this into your job briefing and job planning. So is it someone who has a lot of experience on that particular piece of equipment, or I've never worked on it before? Could be a big difference in risk. Training, what type of training? How often have they had training? When's the last time I had training? Do I have documentation that the person is proficient? So has there been some component? Those type of things. And then also PPE, from a standpoint of human factors. Do I have personal protective equipment? Is it available? Or do we share it? And if I'm a contractor and I have 2 arc flash hoods and I have 50 guys on 40 different job sites, the risk is greater that I may not have it when I need it, and the risk of someone doing the task without it. So we consider those kind of things. The last one is the avoidance and limiting of the injury. So can I avoid the injury if it happens? Can I limit the injury if it happens? And can I identify so I can avoid it altogether? So that could be the difference of how do I know the power is on or off? Have I used a multimeter? Do I have, Grace Engineering has the voltage indicators, the VTS type units. So do I have a way to verify it's off before I'm even exposed to the hazard? So those type of things that we do, we can estimate the risk. So when we estimate the risk, then there's a way to calculate those risk estimates. And based on those risk estimates, then we get a risk calculation, and there's actually a rating system in Annex F that shows us how to determine if that risk is extreme, major, minor, or acceptable. And based on where that falls, and I'm really simplifying, but where that falls, you may need to determine that some risk control methods are required because it's not acceptable at that level. And then once you do the risk control efforts, then you need to determine, does that risk control then make it more beneficial that it is acceptable. And one of the simplest things to do is wearing PPE. because when you do your base risk assessment, you're assuming that there's no PPE being worn. So you're basing the risk of the outcome and everything if the person is not wearing PPE. So the first simple thing to do is reevaluate with proper PPE on. And, again, we can go a lot deeper into that, but just, giving you an example of how you go about doing that, that would be an example of that. So the slides are not available, unfortunately. You can, the recording of this is going to be on EasyPower. We have the 4-hour course version at qualifiedsafety.com, so you can call our email here, and we can give you the options for how to purchase access, whether it's an online training individually or as a group. Standard labels from EasyPower. Again, you can go to EasyPower and you can get some templates and examples. They are all ANSI Z535 compliant, and now they do have, here recent times, the ability to, you can generate not only your labels, but also some different variations of the labels, so you can customize a little bit. Just reading down through some questions. Can you provide a sample template RFP document to be used as a starting point? I would say give me a call, and I can, discuss with you, what we can help you with there. Are there any similar norms or standards in European countries? The best one to go off is IEEE 1584, and then the NFPA 70E. They have the most language. IEEE also has a document. 3007 is the standard number. .1, 2, and 3. And there is some information there. I believe it's .3. I apologize, don't quote me on that. I don't have it sitting in front. It's .1, .2, and .3, and one of those actually is information about the arc flash analysis process. And it's got some good information in there. A lot of what we talked about, you have to go deeper than just what's written in the standard, and you have to look at the big picture. At the end of the day, if somebody gets hurt, you're going to have to defend what was done. So again, if you write your RFP and you write it in a way that gives as much detail as possible, that very second slide I showed you, lack of direction is implied direction. Specify what you want, and that way people are providing it to you. Anything that's kind of loosely written, yes, we're providing you a study that's compliant to this or that, that's open-ended. That makes it real hard for you as a person. You're basically letting that person provide the responsibility, so to speak, of ensuring that your system is properly done without giving you the details. So again, thank you for attending. The recording will be up on EasyPower hopefully early next week. And if you have any questions or interest in attending some of the other courses related to the data collection boot camp, as well as the full 4-hour version of this course, again, you can reach us at the number or email shown on the screen. I got one more question I'll go ahead and answer here. Regarding assumptions, would you recommend an RFP stating when a utility company doesn't provide min and max primary utility source, the consultant shall use 50% min and 200 for max? I'm not going to get specific into what I'd recommend as far as the actual percentage. Definitely you're going to need to get a min and a max. Utility company will provide that. You may have to go through the customer to get authorization, or the customer may have to give that. I would be happy if you send me an email, send you a utility form that we would use that you could send to them. The best recommendation I can give you there is just don't wait till the data is collected to ask for the utility information, because it could take a lot of time and a lot of headache, getting that information. Definitely min and max. There's no reason they can't give you min and max. I would still be cautious if you do the assumption you're still pushing hard to get the actual information and then plug that in. That's another one long term. A lot of loose and a lot of examples of information out there, but I would check that information no less than once a year and continue to be in contact with the utility company. I'm not sure, where you guys may be, where you're at. Let me know. Send me an email. I'm sure we do studies all over the country. I'm sure there's some people that we can contact to help you with that. A lot of times it's just that they won't talk to a third party. They want to talk to the account holder, or they have an authorization form or something that they need to allow them to talk. Yeah, just be careful about doing that. If it's not a part of the original proposal or RFP, I would definitely spell that out, that, you know, it's not your responsibility to get it. It's the customer's responsibility if you think you're going to have some difficulty, and make them make that decision as the client, how they're going to handle that. Definitely just to protect your liability. So, all right, I'll go ahead and we'll close the recording up on this webinar. If you have any other questions, again, on the screen, a phone number and email, and be happy to address any of your questions. Thanks a lot.